If you've written code for a living anytime in the last 15 years, you share a collective trauma. It's 4:45 p.m. on a Friday. You push a minor CSS adjustment, maybe you changed a button padding or updated an ID, your CI/CD pipeline starts running, and then, bam. The test suite fails. Not because your code is broken, but because some brittle, hard-coded Selenium or Playwright selector decided to throw a temper tantrum. We've accepted this as the tax of shipping software. Maintaining tests takes longer than writing the actual features. In fact, engineering surveys show that over half of all code written this year is AI-assisted. We are producing software faster than humans can possibly test it, which means traditional QA automation is dead. We are entering the era of Agentic QA, systems that don't just execute code we write, but open a browser, explore your app like a human, visually find bugs, and fix their own broken scripts on the fly. Today, we're looking under the hood of the exact technical architecture frontier companies are using to build autonomous QA agents. No marketing fluff, just pure software engineering. When most people hear AI QA, they think, oh, you just asked ChatGPT to write a Playwright script. No. That is last-gen thinking. If you just use an LLM to generate code, you've still got code that can break. The frontier approach mimics a human junior QA engineer. Look at the paradigm shift. In traditional automation, the pipeline is rigidly sequential. A human manually designs and writes a test script. An execution tool runs it blindly, and if it breaks, a human has to pause their day to analyze the failure log. Agentic QA completely flips this on its head by running an autonomous, self-correcting lifecycle. First, the AI independently explores the application to discover its real-time behavior. Then, it programmatically generates its own test cases based on natural language product requirements. It executes those tests natively, utilizes deep system and network logs to analyze any failures, and automatically heals its own test scripts as your UI changes over time. Let's look at the actual stack powering this. If you're a startup or indie developer, you are likely pairing Playwright with frameworks like Stagehand or browser use, running execution via GitHub Actions. If you're at an enterprise level, platforms like Mabel or Test Sigma are abstracting this into massive self-healing layers. But how does it actually work under the hood? Let's break down the technical blueprints. This is the blueprint of a fully autonomous QA system. It is broken into layers of perception, reasoning, and action. The pipeline kicks off with your raw product requirements, which feed straight into a central planning LLM. This model acts as the brain, determining whether the agent needs to generate static test code, explore a newly deployed feature, or run a targeted risk analysis. From there, instructions flow directly down to a native browser agent powered by Playwright. As that browser agent interacts with your application, it doesn't just look at elements blindly. It simultaneously ingests 3 distinct parallel streams of telemetry data: the structural DOM tree, pixel-perfect visual screenshots, and live system network logs. All of this high-fidelity context is funneled directly into a multimodal vision model and an evaluation layer to verify if the application is actually working. Let's look at how this works on the ground. At the very bottom, we have the execution engine. Playwright is completely dominating this space over Selenium. Why? Because it exposes raw access to the Chromium DevTools protocol. It lets our AI tap directly into JavaScript evaluation, network routing, and pixel-perfect screenshots. Layer 2 and 3, Computer Vision and DOM Fusion. Here is where things get interesting. Traditional automation relies on code like this: await, page, ... click, oblige, submit, btn. If a designer changes that ID to IJU submit button, your test crashes. An AI agent doesn't look for strings of code, it looks for meaning. You tell it, click the login button. Now, early AI attempts sent the entire web page DOM or raw high-res screenshots straight to GPT-4o or Claude. But doing that on every single action is incredibly slow and turns your API bill into a financial horror movie. Instead, modern systems use a hybrid approach called visual grounding. The system first strips down the DOM into a lightweight accessibility tree, filtering out everything except interactive elements like buttons and inputs. If that fails, it triggers a fallback. It takes a screenshot and passes it to specialized UI vision models, like NVIDIA's Locate Anything or open-source Qwen2VL variants. These models don't return code, They look at the image and return raw bounding box JSON coordinates containing an element label alongside precise pixel boundaries for the target object. The agent then translates those coordinates back to a precise Playwright mouse click. It didn't care about your CSS class names or ID changes, it found the button because it saw the button. But how does the agent move around without a script? This is layer 4 and 5. Autonomous exploration and state graphs. Instead of a linear test path, the AI runs an internal reinforcement learning style loop. Observe, reason, act. As it interacts with an application, it maps out the entire site as a directed graph. Every unique page state or URL acts as a distinct structural node, and every possible user interaction, like clicking a link or submitting a multi-field form, serves as a connecting edge. If the agent clicks Add to Cart and the application state shifts, a new node is dynamically logged in the system map. Many platforms are storing these application graphs inside vector or graph databases. This allows the AI to calculate test coverage mathematically. It looks at the map and says, hey, I haven't verified the edge case where a user tries to check out with an empty cart or an expired coupon, and it designs a test workflow specifically to hit that node. Layer 7. Self-healing. This leads directly to self-healing. When an element moves or text changes from sign-in to login, the AI evaluates the old state versus the new state using structural and embedding similarities. It realizes it's looking at the exact same logical component, executes the action seamlessly, and creates a background ticket to update its internal locator model. Zero human intervention. Now this sounds like absolute magic, but let's talk about some harsh engineering realities. If you try to build this tomorrow, you're going to run face first into 3 major bottlenecks. 1. The hallucinated click loop. Web apps are highly asynchronous. If an agent tries to click a button while a loading spinner is blocking the page, the vision model might misread the UI, causing the agent to get stuck in an infinite loop. You must implement strict state verification, forcing the browser agent to wait for network idleness and element stability before letting the LLM think. 2. Token latency. Waiting 3 seconds for a frontier cloud model to respond to every single click makes your test suite agonizingly slow. This is why teams are migrating away from general-purpose LLMs for interaction steps, using local, fine-tuned, smaller models for visual grounding, and saving the massive, expensive models strictly for high-level planning. 3. Multi-agent specialization. Trying to make one single prompt handle everything fails at scale. The newest architectures break this down into a collaborative multi-agent workflow. This passes tasks downstream sequentially through dedicated instances. A planner agent sketches out the test criteria, an explorer agent maps the system paths, a test generation agent scripts the code parameters, an execution agent triggers the browser environment, a debugging agent isolatedly dissects system logs upon errors, and a reporting agent automatically formats clean tickets into Linear or GitHub. But here is the ultimate reason this technology matters. The hardest problem in software engineering today is no longer testing deterministic websites where button A always leads to page B. The real frontier is testing AI applications themselves. How do you write a unit test for an LLM wrapper, a chatbot, or a complex RAG system? You can't use a traditional assertion statement like assert response, shirkbomb, expected string, because AI outputs are probabilistic. They change slightly every time. Testing an AI requires an AI. Teams are now utilizing LLM-as-a-Judge scoring metrics. We run multi-turn adversarial QA agents that actively try to inject prompts, break guardrails, and induce hallucinations in production applications. An evaluation layer then grades the output using specialized formulas to calculate things like context, precision, and faithfulness. We are entering a loop where AI is writing code, AI is testing that code, and AI is evaluating the AI that tested it. If you want to stay ahead of the curve, stop spending your weekends fixing broken XPath selectors. Start learning how to build and orchestrate browser agents, because the future of QA isn't automated scripts, it's autonomous intelligence. I've left links down in the description to some of the open-source frameworks like Stagehand and research papers on UI grounding models we discussed today. If you found this technical breakdown valuable, hit that subscribe button, smash the like button, and let me know in the comments. Are you ready to hand your test suite over to an AI agent? I'll see you in the next one.